Okay, so on your example sheet, the backside number 3. We had kind of started this yesterday, but we didn't finish going through it. So let's do that now. Okay, so it says a kitten is falling from the branch of a tree 4 meters above the ground. And you're standing 6 meters away. How quickly must you accelerate to catch the kitten? So there are two parts to this question. There's the kitten falling, and then there's you. So the kitten is falling. That means VI is 0. It means acceleration for the kitten is 9.81 meters per second squared down. And it says the kitten is on a branch that's 4 meters above the ground. So it's going to fall 4 meters down. For you, it says you are standing 6 meters away. You're standing. That means your VI is 0. You're 6 meters away. That means your delta D is 6 meters. And the question wants to know your acceleration. What connects you and the kitten? So if the kitten is on this branch, and my apologies, this is going to be scary, but here's the little dude on the branch, and he's going to fall, and you're standing over here, and you're going to run this way. The amount of time that the kitten falls is the same amount of time you have to get there. So if you can find the time for one of them, you will have the time for the other. If you take a look at your givens, you only have one unknown for the kitten. That means you can solve here. Once you get the time for the kitten, then you'll only have one unknown for you, which means you'll be able to solve it. So we have a VI, an A, a delta D, and we want a delta T. So for the kitten, you're going to do delta D is equal to VI delta T, 1/2 A delta T squared. And this is kitten. Okay? The kitten's VI is 0. You're solving for time. Multiply both sides by 2 to get rid of the 1/2, and then divide by A. So you'll have T squared is equal to 2 delta D over A. So 2 times 4, it's about 8, divided by 9.81 meters per second squared. And that's going to be T squared. So 8 divided by 9.81, and you get 0.815, but then take the square root. So you get 0.903 seconds. So that's the time for the kitten, but that's also the time for you. Okay, so once you have that, so now you can get your A. A VI, delta D, A, and delta T again. It's going to be exactly the same equation. So delta D is equal to VI delta T, 1/2 A delta T squared. Again, your VI is 0. This time you're solving for A. Multiply both sides by by 2 to get rid of the 1/2. Divide by T squared this time. So 2 delta D over T squared. You were 6 meters away, so 2 times 6, that's about 12. And then it's at 0.903 seconds that you just found. And keep all the decimals. You don't need to round your time. You have it in your calculator. Okay, so you're going to do 12 divided by that time you have in your calculator. And I believe you get 14.715 meters per second squared. Done. Okay? So again, the trick in these questions is separate your givens into parts and then figure out how are the two parts connected. All right, our next question. One object is stopped, a second one passes it, and then the first one accelerates to catch up. For example, you're on a bike but stopped at the side of the road when a friend on a bike goes by. Okay, so here you are on your bike, and so this is you, and your VI is 0. Okay, but a friend comes by on their bike. Whoops. Okay, so this one is you, and this one that I'm going to write the givens over here will be your friend. So the friend goes by going 12 meters per second. Okay, so 12 meters per second. You immediately start out to catch up, accelerating at 0.8 meters per second squared. So 0.8 meters per second squared is your acceleration. How far have you traveled when you catch your friend, and how long did it take? So your friend, it doesn't say anything about your friend speeding up. So your friend maybe doesn't know you've decided to go after them. So they're just going a VF. And so then the question is, you want to know how long before you catch. Okay, so at some point up here, the two of you are going to be together again. Okay, you will have caught them. Okay, so what do we know? What does that mean? It means that however long it took you to get here, that's how long it took your friend to get here. It means whatever the delta t's are, they're the same. And it means that whatever the delta d's are, they're the same. Okay, so what would be the delta d for you? You have a vi at a at t, it would be vi delta t plus 1/2 a delta t squared. This is for you, but your vi is 0, so that goes to 0. What would the delta d be for your friend? Well, we could get it from the VAV equation. VAV is equal to delta d over delta t. So delta d is equal to VAV times delta t. So because your friend isn't accelerating, then it would just be VAV delta t. Now the thing is, you can't find either of these because you don't know your delta d and you don't know your delta t. You don't know your delta d, you don't know your delta t. But you know that they're equal to each other. So where this delta d for you is, fill in your equation for delta d, 1/2 a delta t squared. And where the delta d for your friend is, fill in VAV delta t. And now you only have one unknown. It's the delta t. You could simplify, you could divide both sides by delta t. And so then you end up with 1/2 a delta t is equal to VAV. And now multiply by 2, divide by a. So t squared will be equal to 2 VAV divided by a. So 2 times 12 meters per second divided by 0.8 meters per second squared. 24 divided by 8, 3. So 30, I think, because it's 0.8. Yeah. So it's going to take you 30 seconds to catch your friend. So the question asked, how long did it take? How far did you travel? So delta t of you was from over here. Oh, actually, I could do it right here. So delta t for you then will be 1/2 the 0.8 meters per second squared times the 30 seconds squared that you just found. So delta t for you, 30 squared is 900. Half of 900 is 450, and then times 0.8. You have gone 360 meters. How far did your friend go? We go back over here and find it for your friend. Delta d of your friend was 12 meters per second times 30 seconds. Lo and behold, they have also traveled 360 meters. And that's how you know that you did it right. So it's just like math equations, two unknowns, right? You substitute until you only have one unknown, you solve for it, and then you go back and you sub it back in to find the other variable, and then you sub it in the other equation as a check. Okay? Let's go to example 5. Two objects start some distance apart and travel towards each other. I'm going to run out of time here. Okay? So you have two bikes 400 meters apart. So here's bike 1, and over here, bike 2. And the distance between them is 400 meters apart. And they begin to pedal towards each other. So that means VI is 0 for both of them. The first one accelerates at a 0.8, so A1 is